In this how to design data problem, the type comment is going to end up with a one of, but not all of the subclasses are going to be single distinct values. So this is what's going to be called an itemization, and it'll be the most complex form of data that we see this week. This is the problem in Countdown Starter. So what we're supposed to do here is design a data definition to represent the current state of a New Year's Eve countdown. So this is something like the countdown ball in Times Square. And we're asked to design a data definition for that. As always, when we design a data definition, the first thing is to clearly identify the information in the problem domain that we're trying to represent. And in this case, the problem statement makes that very clear to us. In particular, it makes it clear that the information falls into one of three categories. The countdown hasn't started, it's from 10 to 1 seconds before midnight, or it's complete. The previous problem we saw, the letter grade problem, also had three categories. But here the categories are different. This first one is kind of distinct. The countdown hasn't started, that's a clear, distinct state. But in this second category, there's not a single distinct value there. There's 10, 9, 8, all the way to 1. So there's a number of different values there. And then in the third category, again, there's a distinct state there. The countdown is complete. So this isn't going to be an enumeration. This is going to be what's called an itemization, because there are two or more subclasses, at least one of which is not a single distinct value. This center one is not a single distinct value. So that's going to be an itemization. And again, after this video is over, I encourage you to go to the design recipes page, go to the how to design data page. This table would remind you that itemization is what you need to use in a case like this, and you can go and read about the itemizations. Do that carefully after this video is over. I'll work through the problem now. So let's see, we start with the type comment as always. So we'll say that countdown is one of, and there's three subclasses. And now we have to decide for each subclass how we'll represent that, what data will represent that. Well, let's see, if the countdown hasn't yet started, that's kind of a distinct state. So we could use any piece of atomic distinct data to represent that. Let's just use false. Okay, we'll use the Boolean value false to represent that the countdown hasn't yet started. Now in the second subclass, let's just say that that'll be a natural number from 1 to 10 inclusive. And in the third case, we also need a distinct value there. And we'll just use the string in this case, complete. So now we've got three distinct subclasses that correspond to the three distinct kinds of information that need to be represented. And we'll do an interpretation here. And I'll use multiple lines for this interpretation. I'll say false means countdown has not yet started. Natural 1 to 10 means countdown is running and how many seconds left. And complete means countdown is over. Okay. And if you want to, you can indulge your inner Virgo and make these line up nicely. And if you don't want to, you don't have to. There's the type comment and the interpretation. Now we need some examples. So we might say, define countdown 1 is, now I'll put a false here. It's an atomic distinct, so in some sense you might find that that example is not particularly illustrative. But maybe I'll have countdown 2 is 10, and I could put a comment here if I want, just started running. Define countdown 3, almost over, and define countdown 4, complete. And that one's clear. So there's my examples. Now we'll set up to do the template. Define fun for countdown C. There'll be some body template rules used. So now we have to go find the first template rule used. And again, we always start by looking at the word right after is in the type comment, and that word is one of. So if we go find the template rules page, again, we can find that by following this link, the data-driven templates recipe link. The one of rule is the rule we're going to use because this is an itemization. The one of rule is also what we used for enumerations, so we know how it starts out. It's going to tell us to make a con with one clause per subclass of the one of. So I'll go back over to the code now, and I'll say cond, and there's 3 subclasses, so there'll be 3 question-answer pairs. And I'll say that the rule that I used was one of 3 cases. Okay, so now I go to the first case. The first case is false. Well, false is an atomic distinct value. And I need a predicate for the question that tests for false. And it turns out there is a predicate that tests whether a value is exactly false. So back at the code, I could put that predicate in. I could say false question mark C. This is atomic distinct, so dot, dot, dot. Atomic distinct false. So now for the second subcase, let's see, this is an interval. So going back to the data templates page, for interval, I need an appropriate predicate. So this is a predicate that, for example, tells me, is it a number between 1 and 10? But I have to be a little careful here. If I just make this predicate be and 1 is less than or equal to C, and C is less than or equal to 10, and let me just do the answer clause quickly so we'll have that out of the way. Since this is an atomic non-distinct, this would be dot, 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 C. That might be what you write, but this particular itemization is called a mixed data itemization. It's a mixed data itemization because there's different kinds of data in it. Not all 3 clauses are numbers. The first clause, the data is a Boolean. The second clause, it's a number. In the third, it's a string. So I have to be very careful here because if I call this template with C being the string complete, this less than or equal right here, this less than or equal is going to blow up because you can't call less than or equal giving it a string as an argument. So because this is a mixed data itemization, we have to guard this less than or equal against being called with a value that isn't a number. And the way we're going to guard it is we're going to say, well, you're only this middle case if you're a number and you're a number between 1 and 10. So I'm going to add one more test to the and. So now if I call fun for countdown with false, this template will go there. If I call fun for countdown with a number that's between 1 and 10, this template will go there. So now I've done the code properly, and I need to add the template rule that I used. Atomic non-distinct, and it's this interval right here. I'll just copy it. Now going back over to the data templates page, there's a note here that says it is permissible to use else for the last question for itemizations and large enumerations. This is an itemization. So we're allowed to use else for the last question. What that means is, right here for this question, I'm allowed to put else. I don't have to put a question that tests whether C is actually the string complete. Let me do the answer quickly. This complete is an atomic distinct, so the answer is going to be that. And now let me talk about why I'm allowed to put this else here, and it's really important. In this course, If you have written a well-formed type comment like countdown, and you later say that a function consumes a countdown, then you can count on the function being called with a legal countdown. And so what that means is, when this template runs in some specific function, if C isn't false and C isn't a number between 1 and 10, then C is guaranteed to be the string complete. You don't have to actually test here whether C is the string complete. What we're saying is that having taken the trouble to do the type comment and having taken trouble to specify the signature of a function, you can count on that being respected. The reason that's a reasonable thing to do in this course is in other programming languages that you will use, there's a part of the programming language implementation called the compiler, which will actually enforce that rule to make sure that it's always true. So it's a reasonable rule for you to start counting on here. So now that I've done this last case, I do need to go and add my template rule used, which is atomic distinct, and it's this complete here. So let's see, I'll run it to make sure everything's well formed. I don't get any errors, so it is well formed, and I will comment out that piece of it. Save the file, and now I've got the data definition for this countdown type.